this. Okay. So good morning once again, no? So anyway, your assignment is extended to August 9, okay? Because our next meeting will be on August 10. Do you follow? Next formal meeting. Any questions so far? Next lecture, no? Online lecture is on August 10. I think you have been informed, no? By the dean that there will be orientation for the second batch of students. But for me, I'd rather give orientation and makeup classes at the same time because there are also a lot of late enrollees, no? Ang daming late enrollees, no? Like for example, in the other classes, no? Ito, mga late enrollees. And then batch 2, okay? Batch 2 and late enrollees, no? So the late enrollees, I suggest you, you attend, okay? So dito, okay. So there's not much, but ito late enrollee, oh. And no, Chang is not a late enrollee, no? This is our, this is our attendance today. But if you have missed the first few meetings, you can, you're free to attend. We are using the same meeting room, okay? So the assignment is due on August 9. Okay? The assignment for the IAS programs, especially the part which computes the average and sum of the first three numbers, the looping part, okay? Any questions so far? Okay. So anyway, let me upload. I-upload ko muna yung solution for factorial, no? With the loop because I have missed this last meeting, no? So our recording, the recordings last meeting are already online, no? I've uploaded them already. So take note, you can, those who are absent can view them in YouTube, okay? Let me add the solution. Ito na. Nandito na yung solution, no? Fourth factorial. Okay? Okay. You can download this, no? We have discussed this before. So, fourth factorial for the loop. Anyway, I have a local copy. This is it, no? Okay. So, we have discussed this before. Now, our main problem is we would like to translate our code from the analytical engine by Charles Babbage, no, to a version compatible with the IAS. Because normally, no matter what language you use, programming language will always be the same. Asylum is here. So that's the concept. But sometimes there are language incompatibilities, no? They're not the same. Like in this case, no? There's a main difference between the IAS, no? Command. One of the IAS commands looks like one of the commands in the analytical engine. There's a close look alike, but there's a subtle difference also, which means that we cannot apply them, no, for the same purpose. Okay, let's view that at the same time. Okay, look at this, no? We would like to use our CF. This is our program code, no? We look the CB. Okay, the CB is count backwards, no? So 1 minus 4 will set the lever, so therefore it will go back. 1 minus 3 will also set the lever, so we'll go back. 1 minus 2 will also set, will go back. But 1 minus 1 will not set the lever, so it will proceed to a pre-PBH, no? Do you follow? Now, however, this is also the instruction set of the IAS. We may expect jump plus to be the exact equivalent. Do you follow? But the problem is, no? Jump plus will not set at 1 minus 1, will still set at 1 minus 1. Do you follow? This is the main problem. So which means that in a loop, no, or in a repetition, for the analytical engine, 1 minus 1 will terminate. But for the IAS, it will just go on. Okay? So, we have the problem shown here. Okay? Ito yung problema natin. I've shown this to you last meeting, right? Towards the end, in pass number 4, okay, this should be our last pass. Okay, when the accumulator is 24, the partial product, and then the last multiplier is 1, right? So the logic is the same. We compute for the partial product, and then we compute for the next multiplier. There are two steps, no? So here we load M1, and then we move M3. So we compute the next multiplier rather than next partial product. So 24 times 1, that's the next partial product, which is 24. And then we store it to the answer, which is M1. Okay. And then the next step is to compute for the next multiplier. So the last multiplier is 1. We load it to the AC, M3. And then we sub M2, 1 minus 1 equals 0. Okay. Okay. And then we have a jump plus. Now the problem is, this is a jump plus. What will a jump plus do? It's indicated that if the number of the accumulator is non-negative, which means 0 and above, it will execute the jump plus. Do you follow? No, it will execute the jump plus. So this is 0 and above. So we will execute the jump plus. We will go to a fifth pass, where we go to the first step, which is to compute the next multiplier, or rather next partial product. We load M1, we move M3. But now M3 is 0. Okay, so 24 times 0 equals 0. So this becomes 0. You follow? And we store it to M1. So the answer is 0. We compute the next multiplier, which is 0 minus 1. So now jump plus will no longer work because this is a negative. So we will go to halt, right? We have terminated the loop. It's good, no? But we have the wrong answer. The final answer is 0. Do you follow? Do you get my point? Okay. So that's the main problem, because we cannot use jump plus is in place of CB. Okay, because they're almost the same, but there's a subtle difference in 1 minus 1. They will differ in 1 minus 1. In the analytical engine, this could have terminated the loop, and we will have the correct answer. Okay, I hope you got the point, no? Do you follow? Okay. So if we will manipulate this program, no, to force jump plus to be used this way, like CB, we will be desperate because it will not work. We will have to change the logic. Do you follow? Ramirez, I have checked your attendance. So we will have to change the logic because they are different, and we will never have it work the same way. Okay, kasi the seed difference is subtle eh. Okay, do you follow? So there are other ways. Okay, so we have to change the logic, but I would like to introduce you a new concept on looping. Okay, you cannot Google the solution to this. Okay, that's the main reason why I postponed the deadline of the assignment, because you cannot do the assignment if you don't have the background. Okay, the needed background. I'd like you to download a part there, which is looping concepts. This is about basic looping concepts. No, I have it there. No, basic looping concepts. Okay, ito. Okay, basic looping concepts in programming. You're taking up intro to programming this semester, right? You're all presently, I mean, no? So this is useful to you, no? Now, in our case, this is critical because we have no other way. There's only one way to loop, which is jump plus and CB. So we need to know how to make loops. Can you download that? No? Anyway, I have a copy myself. No? If you download that, no? This is the no. Okay. Looping concepts. A loop is a concept in programming. Okay, it's a concept used to do a repetition. Okay, what is a loop? Anyone? Have you done this already? Have you done this already in your intro to programming? Where are you now? Assignment state. You must have done assignment statements, right? If I were your teacher there, most probably you're already teaching branching and looping. Is that correct? If then else, am I correct? What are you discussing in your intro to programming? Anyone? What topic? C++ ba kayo? Are you using C++? Wala pa. Pero if malapit na. But you're using C++, right? Okay. So no problem. This is almost the same. Okay. So this will be useful to you. A loop is a sequence of instructions that is continually repeated until a condition is reached. This is also called a repetition. Like the computation of sums, no, and averages, we will have to repeat a sequence until a condition is reached. Computation of factorials, also a repetition, is called a loop until a condition is reached. Okay. Now, repetition control structures define our commands in a language. Okay. There are commands in a machine which define how loops are organized. No? They follow? So, any questions? No? We'll look at the control structures. So before we look at the control structures, it's important to know the bodies of a loop, the parts of a loop. A loop usually starts with a head. Okay? The head is the first command that is repeated with a loop. Do you follow? And it's a tail. The tail, it has a tail. The tail is the last command that is repeated within the loop. The set of commands between the head and the tail is called the body. Now, the body composes the repetition. Do you follow? The body is the part which is repeated every time a condition is reached or not, no? Depending. So here's an example. This is our example. This is uh, our factorial program in the analytical engine. Do you follow? What it does is repeatedly compute the partial product and the next multiplier, right? Do you follow? Wala tayong multiplier, no? Wala tayong mul. I don't think this is, but this is just an example. Okay? Do you follow? So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Babalik siya. It goes back there, no? This is the head of the loop, which is the first that is executed. Then we will have a load, another store, a plus, a load, a store, and then CB. CB means go back to the head. Do you follow? This is our tail, the last part of the loop. Okay? So the composition of the body is everything in between the head and the tail. Okay? Any questions so far? No? So you will take this up also in your programming courses. No? So this will be useful. In any language, this concept remains the same. Okay? I'm trying to show you this because it's very difficult to solve the factorial repetition in the IAS, no? Given the IAS instruction set. No? What are the different looping structures? No? Usually there are two. No? The first is the bottom-up structure. It's a structure where repetition goes from the tail. No? The repetition goes from the tail to the head. Do you follow? The example we have for the analytical engine is a bottom-up structure, which means that there will be a first pass, no? A normal pass, and then at the end, the repetition will go back depending on the condition. Okay? This is a repetition pass. It goes back to the head if the condition is reached. Do you follow? The loop terminates when the condition is not reached because the execution will go out of the body. When we say the loop terminates, the execution goes out of the tail. Okay? Any questions so far? So this is what we have. Now, we have seen that the bottom-up structure will not work for computing the fourth factorial in the IAS. Do you follow? So the bottom-up structure will not work for computing the factorial in the IAS. It does work for the analytical engine. Okay, so any questions so far? Any questions? Asombrado. Yeah, let me check. Asombrado. Yes, you're here. Okay. So that's the bottom-up structure. Yeah, sorry. The second is the top-down loop or the top-down structure. Okay, this is a little different, no, but the main difference is the bottom-up structure will always have a repetition, no? At least one repetition. Okay, the top-down loop may not have a single repetition. Okay, it may result to a zero repetition. Why? Because it's a looping structure which goes directly outside the bottom or after the tail based on a condition. Do you follow? So from the head, there's a condition. The main difference between bottom up and top down is the placement of the condition. In the top down loop, the condition is at the top. Do you follow? Okay. In the bottom up, the condition is at the bottom. Do you follow? So the direction is determined by the location of the condition. So if the condition is at the bottom, it's bottom up. If the condition is at the top, it's top down. Okay? Do you follow? No? So here is an example. We have a head. This is a different language. No? This is the IAS language. Then we have a condition. If the condition is reached, we will terminate, go outside the tail. This is the outside the tail is a halt. Okay, jump to itself is a halt. Okay, any questions so far? If the condition is reached, we will terminate the loop. This is called the termination branch or the termination pass, where the body of the loop is skipped. Okay, so which means that it may happen that the loop is not executed at all. Unlike in the bottom up, there will always be an execution of the body of the loop. Okay, any questions? So pwede siyang hindi ma-execute. And then, if the condition is not reached, that's when the body is executed one by one. We do a load, we do a mul, store, load, add. And then, at the bottom, we will have a repetition jump without a condition. Do you follow? So repetition is done without a condition at the bottom, which means we will jump directly to the head. Okay? Do you follow, everyone? So you get the difference? Any questions so far? Any questions? So I will proceed, no? So there are two types of conditions, no, that are used in a loop. A condition for termination terminates the loop when the condition is reached, which means it goes out of the body. A condition for repetition or continuation repeats if the condition is reached. Okay. Usually in a top-down loop, the condition is a condition for termination, which means that if this condition is reached, we will terminate, go out of the loop. Now in a bottom-up structure, the condition is a condition for repetition or continuation, which means that if this condition applies, we will go back. Okay? Did you get the difference? Okay. Now there are other looping elements such as counters, accumulators. No, you will take them up in your intro to programming course. No, I will not take them up anymore. But obviously we will have a counter. Okay, which is the counter for the next multiplier. It's also a counter. So any questions so far? So the thing is, why do we have two structures? Because if the first structure doesn't work, we will use the second structure. Do you follow? Do you get my point? So it's here. Now, we know that this top-down structure, rather, this is a bottom-up structure, version 1, which doesn't work. Okay? So what we will do is revise our logic and use a top-down loop. No? I'll erase everything from here. This is the same. Okay? This is the same program, but this time top-down. Top-down, okay? Do you follow? Do you follow? we have revised the logic. Okay, so we have a jump 4 to 19 because our actual command is in 4L. 0 to 19 no? Because it's L, and if it's 20 to 39, it's R. Do you follow? So M of 1 is our partial product, this one. And our M of 2 is our increment or decrement. This time I think, yeah, that's an increment, no? Because we start with negative values. Okay? And then M of 3 is our next multiplier. Do you follow? Any questions so far? So this is our first command. Load absolute negative of M1. Okay? Now, this is a strange command. We don't have this in the analytical engine. But we have this in the IAS. That's the main reason why. Ito yun, this command, load negative absolute, which means that whatever the value is, load the negative, always the negative to the accumulator. Do you follow? We have this. Okay? Do you follow? Close ko na itong aking ano. Okay. So anyway. Okay. So load the negative absolute of M1. So which means that, okay, what is loaded to the accumulator is negative 4. Do you follow? Do you follow? Now the contents is accumulator receives negative of M4 of M4 of 4, which is M of 1. And then we add M2. So the actual content is negative 4 plus 1 because M of 2 is 1. Do you follow? I'm sorry, let me just comment this. The actual content is negative 4, which is the accumulator, and add our increment, which is 1. Okay, so the accumulator will become negative 3. Okay, and we will store the next multiplier, which is negative 3. Store it. Do you follow? This is now the head of the loop. Any questions so far? So we have just computed the next multiplier, which is negative 3. So we have a jump plus. Okay, jump plus 9, 0 to 19, which means we will go to 9L. Do you follow? This is the condition for termination. If the accumulator is positive, we will skip the loop, go to the bottom, and halt because we will have nothing else to do. Do you follow? So dito, this is a top. Go to the bottom. Okay, if it's a plus. Do you follow? Any questions so far? Any questions? Okay. Okay. So the question is, at this point, what is the value of the accumulator? Is it non-negative? Anyone? What's the value of the accumulator? Is it non-negative? Yes or no? Are you sleeping there? Negative. So which means we will not execute the jump plus. Do you follow? Which means we will proceed to the body of the loop. So we load M3. Okay. But this is load absolute. Okay, which is also part of the instruction set. Load absolute of M3. What is M3 now? M3 is negative 3. Right? When we say load absolute of M3, the accumulator will have positive 3. Okay? Because it's negative 3, but the load absolute will remove the negative. Okay? Mul M1. So what do we mean by this? Mul M1. M1 is currently 4. So this is 3 times 4. Do you follow? Because we are multiplying the accumulator with 3, which is 3 with 4. Okay, so the accumulator will become 12. Okay? Any questions so far? So hindi ko na I'm not going to show the micro instruction here already, no? I'm not going to show the micro instruction anymore. We know we can just trace. Okay? Actually, ganito lang yung ibig sabihin nito, no? This is AC receives negative of ano. This AC receives AC plus M2. This, you know the logic. Okay? I'm not going to show you that anymore. Store M1, which means that this is AC receives M of 1. Do you follow? Sige, sulat ko na lang. This is AC receives AC times M of 1. Do you follow? And then we have load M3. AC receives the absolute value of M of 3. Okay. Okay. And there this we have AC receives M of 3. This is not absolute but M of 3. Okay. Ito, AC receives absolute of negative of the absolute of M of 1. Okay. Anong size ito? 14. The size here is 11. So we'll change this to 11. Okay. Okay. So ganun. Do you follow? So we are at this point. We have store M1. So AC receives M of 1. So AC is 12. So M of 1 will become 12. Okay. Do you follow? Do you follow? We now have computed the next partial product, which is 12. And then we compute for the next multiplier. We load M3. Okay, M3 is negative 3. So we have this as negative 3. Okay, add M1. So M1 is our increment, which is always negative 1. So this is negative 3 plus 1. Okay, so negative 3 plus 1, this becomes negative 2. Do you follow? Okay. And then at this point, we don't have a condition, but we are going to force jump to 50 to 19, so which is 5L. Do you follow? We force jump. So we will not execute a halt. We will force jump to the head of the loop, which is 5L. So we will have a second pass. During our second pass, our accumulator is negative 2. Our M1 is 12. This is 1. This is negative 3. Do you follow? So this is a top down. So we are going to go up. We are going to go up without any condition. Okay. So force jump. So we'll go back to 5L. Okay. Store M3. So we will have it. We'll just copy this. Anyway, we know what this is already, no? Store M3. By M. Sorry, no? We'll copy this. Ayaw niya mag-copy. AC receives M3. So M of 3, what is M of 3? This is negative 3. No. Store M3. Baligtad. No, this is M3 receives AC. I'm sorry, this is wrong, no? M3 receives AC. Let's copy this. Okay. M3 receives AC. Right? Because store M3, because it's store. So M of 3, AC is negative 2. M of 3 becomes negative 2. Do you follow? I have to store it here. And this, then we say jump plus. What is the value of AC? Is it positive or negative? Anyone? The value of AC is negative 2. So this is negative. So we will not, okay, we will not skip the loop, but we will go inside. They follow? Kasi jump plus will not execute. Okay, so we load M3. which is the absolute value of M3, which is 2. Okay, mul M1. So this is 2 times 12 because M1 is 12. And we store M1. Okay. Anyway, what is load M3? AC receives M of 3. And then this is AC receives AC plus M of 1. Okay, let's just copy this. That's what it does. So we are here now. Mul M1 2 times 12, so this becomes 24. Do you follow? Okay. Store M1. So AC receives M of 1, so the M of 1. Store M1, baligtad, no? M of 1 receives AC. Store man. This is also wrong. Let's look at the store. Yes. All stores are the other way around. Load is AC is the recipient. But in a store, the memory is the recipient. Okay. So we have store M1. So M1 receives AC. So this now becomes 24. You follow which is our next partial product. So after computing the partial product, we compute for the next multiplier. We load M3. So this is now negative 2. Okay. Negative. We add M1. So this is now negative 2 plus 1. So this becomes negative 1. Okay. And then we jump back to the top. Okay. When we jump back to the top, this is negative 1. This is 24. This is 1. This is negative 2. Do you follow? Without any condition, we jump back to the top because this is a top-down loop condition. So we store M3. So we'll just copy this anyway. You know what this is? Okay, do you follow? Do you follow? Meron ba tayong dito? Meron. Okay, let's copy this. Any questions so far? Save as kumuna na. Okay. So we'll go to the next pass. Store M3. M3 receives AC. Okay, so the accumulator is negative 1, so this AC becomes negative 1. If from negative 2, it becomes negative 1. Any questions? M3 receives AC. Then we have a jump plus. Will we jump? No, because it's still negative. So we will proceed to the body of the loop where we have load M3, which is the what we have. This is absolute load, absolute M3. Okay, so this becomes positive 1. And then we mul M1. So this is 1 times 24 because M1 is 24. This will be 24. Okay, any questions? And we store M1. So now M1 becomes 24. Do you follow? Do you follow? And then we compute the next multiplier. We load M3. M3 is negative 1. Right? So this becomes negative 1. And then we add M1. So this is negative 1 plus 1. So this becomes a 0. Do you follow? And then we force jump. Okay? We force jump back to here, no? Do you follow? We force jump. Do you follow? So force jump tayo dito. We are on the fifth, or rather fourth pass where our accumulator is 0. Our answer is 24. This is a 1 and this is a negative 1. Okay? Okay. We store M3, which means the accumulator is stored to M3. This becomes a 0. Now, what is a zero? A plus or a minus? Anyone? To IAS, this is non-negative. Do you follow? This is non-negative. So jump plus will go to 9L. And we will have a halt. Okay? So now we have the correct answer, which is 24. And our value is a zero. This is already positive. We will halt. Okay? Any questions so far? We have the correct answer. So you see, if the bottom up structure doesn't work, we will apply the top down structure. No? So this works anywhere in any programming language. Do you follow? Do you follow? No? I will upload this again. Okay. Where's that? Must have to transfer this. Dapat ilipat. Okay, hindi na lang, no? Dapat ilipat natin yung looping concepts. This is what we don't like with the okay. And then we'll edit this. Okay, the worksheet, which is the IAS loop factorial. Okay, close this first. And then I'll upload this. So you have the solution there. So obviously you can apply the same concept to compute for the sum and average. So now you can do the assignment. There's no reason why you can tackle the assignment. Okay, which is sum and average of the first three numbers. So with loop and without loop. Okay, computing the factorial is like computing the sum. Huh? You know the difference already. I don't have to elaborate because that's your problem. Okay, figure out how to apply the concept of factorial to compute the sum and average. Okay. Any questions so far? No. I'm not going to introduce any new lesson anymore. Okay, because yeah, because we will have to cope up. No, the other group will have to cope up. So no new lessons. You have what it takes to solve the assignment. Ito lang naman looping Okay? Okay? Any questions so far? Did I miss anyone? We'll have to dismiss, no, at this point. Okay? The second batch and the latecomers, see you tomorrow. Second batch and latecomers, see you tomorrow, okay? Everyone? Second batch enrollees. Late enrollees, no? Okay? For the first batch, okay? Most of you here are first batch enrollees. Okay, those who have missed the first few meetings, you are free to attend, no? You have the same meeting room. Okay, please check your email. I have emailed the details. No? Okay. Any questions? Did I miss anyone? Kalubag, are you there? Dapat nandito na lahat. Kalubag, are you there? Wala si Kalubag. Okay. And then we have Ramis. Torres. Okay, sumobra tayo. May ibang taga ano. We have 28. Everybody should be here. Lim. Giancarlo. Wala. Navarez. Simon. Simon is, I think, a latecomer. No? Valmoria.
Sir, present ko, sir.
Sino ito? Valmoria?
Yes, sir. Si Balmorian, sir.
Did I miss anyone else? Let me check. No, I'm just finalizing now. Valmoria. Yep. It's here.
Sir.
Yes. Kamatsu is here. And I'm just checking the attendance. No? Kulang. So yeah, that's correct. There's 29 of you here, and we have 38. So a few students are absent. Okay. So any questions? So see you on August 10. Do you follow? August 10 will be our next meeting. So in the meanwhile, you solve the assignment. Okay. Although the latecomers and those who are frequently absent, you can attend the meeting tomorrow. Okay. Thanks everyone. I'll upload the recording this afternoon. Okay.
Sir.
Okay, thank you.
Okay, sir. Thank you, sir.
Thank you, sir.
Thank you.